Okay, so as we continue to talk about, well, actually, now that we're starting, as we start talking about quadrilaterals, it's going to get confusing because you're going to have to differentiate between what's true with one shape and what's true with another shape. Okay, as an example, you all know that a square has 4 right angles, yes? What other quadrilaterals have 4 right angles? Do you know at this point in time? Rectangles. Which other ones? So therein lies the problem. Let's go. Parallelogram is the first one. Oh, it works better when you plug it in.
Technology these days, you know.
Getting old dogs and tricks. There we go. There's a parallelogram. Manny, what's a parallelogram?
4 angles. 4 sides. No. All 2 of the sides would be like they're parallel to each other. Yeah.
Right, so let's review. It's a parallelogram, so you're saying that.
These sides are parallel, these sides are parallel.
Okay. Now, if I was writing a textbook, I couldn't write these sides and these sides. How would you describe it?
It was like opposite sides.
Bingo. Opposite sides are parallel. Well done. We're going to talk about definitions, and then we're going to talk about properties. So that's all you need to know as far as the definition of a parallelogram. Why are we doing hierarchies? Again, because it becomes relevant. Notice that a parallelogram is a quadrilateral. Is a quadrilateral a parallelogram? Rich? Let me ask the question again. A parallelogram is a quadrilateral. You agree? Is a quadrilateral a parallelogram?
Yeah.
No.
Actually, no.
Correct. Okay. Golden retriever, dog. All golden retrievers are dogs. Not all dogs are golden retrievers. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. So why do we throw the word quadrilateral in there? Because it defines a bunch of other stuff that we don't want to bother with. We know now that a parallelogram has 4 sides. It has 4 angles. Okay, because it's a quadrilateral. And then what makes that parallelogram special is it's got the opposite sides parallel to each other because it's a parallelogram. Notice the arrowheads there distinguishing that. Then we got a whole bunch of other things that are true about it. The opposite sides are congruent. The opposite angles are congruent. I'm going to go quickly through this because I hope you found the slideshow on this, right? So you don't have to write all this down. Yes? Okay, good. So I'm just going to go and we'll get caught up. So there's a picture illustrating that. Notice the different tick marks. I've got 2 tick marks on the top side and the bottom side showing that they're equal. I've got 1 tick mark on the right side and the left side showing that they're equal. Okay, so that means that not all 4 sides are equal, just the opposite sides. Same thing is true with the angles. I got 1 arc mark across 2 of the angles and then 2 arc marks across the other 2 angles. How are we doing so far? We good? Excellent, great, let's move on. Woohoo! Consecutive angles are sub. Aiden, what does the word consecutive mean?
The one's right after.
Beautiful. For our purposes, excellent definition. For our purposes, we're going to do the angle next to it. Probably should have used adjacent. And the diagonals bisect each other. I honestly don't remember. Have we defined the term diagonal? No? Okay, a diagonal is a segment that connects non-adjacent vertices in a polygon. I'll say that again. A segment that connects non-adjacent vertices in a polygon. The reason it's non-adjacent is because if it's adjacent, it's just the side of the shape. Okay, so those green things are diagonals. We drew a bunch of diagonals and polygons on Wednesday when we were breaking polygons into all the triangles. Those are also diagonals. Quadrilaterals only have 2 diagonals. As the number of sides get bigger, the number of diagonals gets bigger. Okay, we good? Am I going too fast? No? Good. All right. Find angle D, please. You'll also see in the notes that it says it is a parallelogram. I'm going to talk while you're working. For those of you that are struggling, you might want to ask yourself, what do those two angles that are labeled in the picture have in common? Then set up an equation, then solve that equation, then plug and chug, then answer the question. We've used that strategy before. Okay, here we go. Ryan, what is the relationship between these two angles?
They're equal to each other?
Beautiful, because the opposite sides in a parallelogram are congruent. So what equation did you set up?
4x minus 9 equals 3x plus 18.
And when you solve that, you get x equals
27.
27. All done. Good to go? No? Why not?
Because that's not angle D.
Correct. So what do I do then?
Since angles A and C are supplementary to angles D and B, you subtract. You plug in x to one of them and then
Okay.
subtract, which you
So
get.
plug and chug.
Yeah.
Angle C then becomes 3 times 27 plus 18, which equals...
27? Wait, no.
No, no. No, 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 no.
99.
99. So therefore, angle D is equal to 180 minus 99, which is 81. Lovely. Now we're done. Good. Well done. Let's give it up for Ryan. Any problems, questions, concerns? Excellent. Moving on. I got 81 also, Ryan. Good job. Now we're going to start some coordinate geometry. What is coordinate geometry? That's when you take all this stuff and you slap it on a coordinate plane. We've done this already with lines and stuff, but now we're going to do some quadrilaterals. So I'm wondering, I've got these 4 points, and I'm wondering, is that puppy a parallelogram? We'll do this a lot. And in fact, it's going to get more complicated because at the end of the chapter, we're going to say, hey, these 4 points make a shape. What kind of shape is that? And you have to do a bunch of detective work. But we'll worry about that when we get to it. Okay, so here we go. Graphing is fun. 1, 1. That's point R. 8, 8. Oh, no, sorry, 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. S. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. T. 1, 2, 3, 4, 5, 6. 1, 2, 3. B. Is that a parallelogram? One answer that will never be acceptable is yes, because it looks like one. So we have to figure out how to prove that's a parallelogram. So let's review what we can do on a coordinate plane. We can find a distance. we can find the slope. And that's about it. So Alina, pressure on you. Would you prefer a distance or a slope? Slope, excellent. So your table is going to calculate the 4 slopes of the sides of the parallelogram. Okay, get on that. Your table, Maya, is going to calculate the length of all 4 sides. Okay? Your table is going to make sure that they don't screw up. Your table is going to make sure they don't screw up. In other words, do the calculations also. You guys are cheerleading. You guys are humming a song. And you 3 are staring into the lights until everyone's done. Okay, go! It got quiet. Are we done? Yeah? Okay. Maya, how long are you guys done back there? You're good? Can you give me the 4 sides then? How long is RS? 5.29. 5.39. How long is ST? How long is TV? I'm seeing a pattern here. I'm guessing that RV is also 5.39? Huh. Whoops. Okay. Lena? What's the slope of RS, raccoon squirrel?
5/2.
What's the slope of salamander turtle?
2/5.
What's the slope of tarantula vulture?
5/2.
And what's the slope of rock lobster viper?
2/5.
Ooh, that's a 5. Okay, let's talk about Maya's answers first. Are the opposite sides equal? Well, that's kind of a dumb question. All the sides are equal. Is that a parallelogram, Maya?
No.
Ah. Oh, dissension in the ranks. Yes or no?
No.
Why not? Are the opposite sides congruent? Yeah. So therefore? Right. Now, it's a little weird because all 4 of them are equal. That's not always going to happen. And in fact, it's not just a parallelogram. It's a different shape, which we'll talk about later, but that's irrelevant right now. So yes, parallelogram. Parallelogram. Check. Alina, what does this tell you about that?
The opposite sides are parallel to each other.
RS is 5/2. VT is 5/2. Our ST is 2/5. RV is 2/5. So you're saying yes, parallelogram. Beautiful. Okay, they better both be yes or both be no. Now, if you're solving that problem, which one do you have to use? You can use whichever method you want. So this group over here had to do 4 slope calculations. Some of you are not so good at slope calculations. This group over here plugged and chugged like mad people into their calculators, yes? Distance formula. Some people can't use a calculator. Some people excel at both. Some people can't do either. But you use whichever technique you want to use. You'll notice what we didn't do on a coordinate plane is look at the angle measures, because that's way too much work. So we're going to keep it simple with slope or distance. Preguntas? Beautiful. Let's move on. Whoops, let's go back to this picture to illustrate what I'm, okay. Come on, there we go. So I drew in the 2 diagonals in a parallelogram. You'll notice a couple things. This triangle is equal to this triangle. This triangle is equal to this triangle. I don't know how you want to phrase that. Maybe opposite triangles in a parallelogram are equal? And what's a little hard to illustrate in this picture, so I'll redraw it, is if I have a parallelogram and I draw in just one of the diagonals, all of a sudden this half is the same as that half. Which is what the slide I'm about to show you says. One diagonal will split the parallelogram into 2 equal triangles. 2 diagonals will give you 2 pairs of opposite triangles congruent. Okay. Not a very helpful thing, but something worth pointing out, because we'll do some work with it later. Let's skip this one. Well, no, hold on. Let me point out one quick thing. We're not going to do all the calculations. We don't care what ST and R are. But I do want to mention this, because what's going to come into being again is the fact that we have parallel lines, and when you have parallel lines, you have some angle relationships. In particular, alternate interior angles. Alternate interior angles. Alternate interior angles. Alternate interior angles. And lastly, vertical angles. So those rear their ugly heads later on. Okay. Which is what that problem illustrates, so we're not going to bother with that. Rectangles. Here we go. Are we good so far? Any problems? Excellent. Change the definition a little bit. A rectangle is not just a quadrilateral, it's a parallelogram, and this is where things get very confusing. So, let's go back to the golden retriever and dog example. Does a golden retriever have all the properties of a dog? Yes?
Yes.
Okay. Does a dog have all the properties of a golden retriever? Not necessarily. Same thing is true here. So what becomes confusing is a rectangle is a subset of a parallelogram. For our purposes, it would be lower down on the hierarchy. But everything that's true about a parallelogram is also true about a rectangle. And then we throw that little extra twist in there that it has 4 right angles. Okay, so I got a picture in here somewhere. Yeah, right there. Now, I went through that quickly, but all of that stuff is pretty much true about, not pretty much, other than the 4 right angles, is true about a parallelogram, and then we throw in the 4 right angles. Pretty good.
What about a square? So like is a square a rectangle?
Oh, we're not ready for that yet.
Okay, so like
Okay,
that's just
let's
not
crawl before we run. Okay? Yeah, let's just slow your roll, sister. Okay. Rectangle. Diagonals are congruent. 4 right angles. But all that other stuff that we talked about is also true. Parallelogram. Parallelogram. Etc., etc., etc. Opposite triangles congruent. Alternate interior angles, vertical angles. All that kind of fun stuff. Oh, but look, right triangles. And you know what comes up when we talk about right triangles? Two things. Pythagorean theorem and trig. This is going to be fun. Okay. Yes, sir.
Can't use trig. The triangles, none of the triangles in the rectangle are right. Oh, never mind. My bad.
I knew you'd get there eventually. By the way, just for giggles, how many triangles are in that? There you go. Thank you, Nate. How many triangles are in that picture? How many? 8 is correct. How many of those triangles are right triangles? Blah, 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 blah. Okay. SO is 200, then NE is. Well, this is kind of a silly question because we've talked about this. If this puppy is 200, how long is this guy? 100. How long is this guy? How long is this guy? How long is that guy? 100. So notice they're all the same thing. However, that's not true in a parallelogram. In a parallelogram, they bisect each other, but it doesn't cut it into 4 equal parts. Only in a rectangle do they break into four equal parts. Parallelogram breaks into 2 equal pairs. Told you this was going to get confusing. But you see that transition, by the way? I worked for hours on that. Let me show you that again. I mean, most people that are new to PowerPoint have it come in from the left or from the right, maybe the bottom, or just have it appear. No, mine comes in from the lower right. I've been doing this a while. It's not my first PowerPoint. FD. This whole thing is 3x minus 7. This thing is x plus 5. Is this a fairly obvious problem? Those two things would be equal, set them equal, similar to the problem we did with parallelogram. Set them equal, solve for x, plug and chug. And then again, we know that this is equal to this, is equal to this, is equal. You know, sometimes you make a slideshow and you realize maybe I shouldn't use the abbreviation AF. That happens every once in a while. You know, you label a triangle and you've used a bad word, or you name a quadrilateral and it turns out to be a potty word. So I should probably avoid that. If you don't know what that means, ask your neighbor; they'll explain it to you. Okay. Oh, I didn't know if you caught that. Let me do that again. Not only can I do the lower right, I can also do the upper left. Okay. Again, this is like varsity level PowerPoint stuff. Angle EFD. EFD. And angle DFG. A lot of these problems, the first question you want to ask yourself is, how do those two things relate? Are they sides? Are they angles? These are angles. How do those angles relate? So what's the relationship between the two marked angles? Which means?
Equals to 90 degrees.
Well said. Couldn't have said it better myself, Gabe. Nicely done. 2x minus 3 plus x plus 12 equals 90. I'm going to assume that you can all solve that linear equation, find x, plug and chug. Is that a safe assumption? Yeah. Okay. I didn't want you to have much PowerPoint information in one slideshow, so I went with a simple appear transition this time. Okay, I don't want to show all my cards early on. Okay, now?
Yeah.
We're done. Fast fact for you. Pigeons rock mathematics. Also known as rats with wings. Okay.